morning, everyone. Thank you for having me. Today, I want to talk to you about TypeScript. But before we get into that, maybe a little bit about me and why I'm talking about TypeScript in the first place. My name is Felix Rieseberg. I'm a senior staff engineer at Slack, where I build the desktop apps in particular, so Slack for macOS, Windows, and Linux. And before I started working at Slack, I was an open source engineer at Microsoft. And when it first came out, I was very strictly against TypeScript. I was pretty much against the whole idea of any version of JavaScript that wasn't actually vanilla JavaScript. My point was pretty much that if you're trying to write JavaScript, JavaScript is the best way to do it. That's how I felt, and I felt very strongly about it. And my opinions flipped once I started seeing a lot of very difficult issues at Slack, at handling a very large JavaScript code base, and sort of became an avid TypeScript fan once we actually ported Slack over, once we ported the Slack desktop application over. And while we did that, while we moved this big application from JavaScript to TypeScript, we found a few things that were easy, very good, but we also found a few things that were bad. And this presentation is pretty much about the struggles that we found and how we dealt with them. But before we get there, I want to motivate this a little bit. Why think about JavaScript? Why improve JavaScript? And I think that JavaScript is a lot more popular than people realize, even in this room. And I have a few favorite examples for what was built with JavaScript. And maybe my favorite example is the user interface in Battlefield 1. The little ammunition counter, the little map. All of this is a TypeScript React application. So we have the 3D game, and on top, we have a React application that is handling things like the ammunition counter. So that's just one example. The other example that I have is the Nvidia Geforce experience. If you have a Windows computer with an Nvidia graphics card, you're running this tool, which is largely built in Node.js. When you do game streaming, video streaming, driver updates, that is all done in Node.js. So JavaScript is handling your graphics card to a decent degree. And if you run any of the Adobe apps, Photoshop, Premiere, Lightroom, all of them launch Node.js the moment you start any of these applications, because that's how they handle their plugins. So that's another place where JavaScript is running. And then lastly, my world, all the Electron applications. I'm one of the maintainers of Electron. There's a lot of Electron applications today. Visual Studio Code, Atom, Slack itself is one of them. All these applications use JavaScript. All these applications use JavaScript in a fairly native world outside of the browser. They use it for things that go beyond a website. And now that we're here, now that JavaScript is being used for all these big applications, these applications usually interact with native code. That's the world that I'm in. So what that means is that every single time I make a mistake, whenever I write bad JavaScript or a bug, I don't end up with a bug in my console. I usually end up with a system crash, because my JavaScript ends up making syscalls, and if I make the wrong syscalls, my application crashes. So the thing that keeps me up at night, the thing that I'm afraid of, is that people can't use Slack because I made a mistake, right? That's what I want to avoid. And to avoid crashes, I need to write code that is structurally sound. I need to know that the code that I'm writing, regardless of whether or not it's good code, I need to know that it's working code. This is the important piece, that the code is working. And let's look a little bit at the problems that we have, or at the solutions that we had before. So I'm not the only one who's writing JavaScript at Slack. Our company now has 2,000 people, which is pretty big for a company that builds only one application. And whenever you have hundreds of people working on the same code base, you try the same things in JavaScript land, right? The first thing that we got was JSDoc. And you basically went ahead and tried to figure out what code is doing. right? We have this little documentation at the top where we say, hey, this is how the method is working. But if I have JS doc objects, I need to trust that whoever wrote that documentation didn't lie to me. And what will happen eventually, sooner or later, is that somebody either makes a mistake or they change the code without updating the documentation. So every single time I do anything in my code, I need to read the whole source code and make sure that all the pieces that I'm calling those pieces in the right way, right? And to go back to that, that doesn't work. It doesn't scale. It takes hours. It simply takes too long. If the code base gets bigger and bigger, you don't really get anywhere. So they're inefficient. They're not fun. I don't want to read the whole source code every single time. And it's not the best use of my time. But the worst part is that I still make mistakes. It doesn't really help. And TypeScript is the thing that came to the rescue for us. And it had a few things that I really liked about it. The first one is that it's a superset of JavaScript. All JavaScript is valid TypeScript. I don't need to change my JavaScript to use TypeScript. It's the same language. I can use all the same things. The second thing I really didn't want is it does not change how JavaScript runs at runtime. TypeScript is a tool that runs only on my machine, on the developer machine, and once I'm done with it, I'm running normal JavaScript. It doesn't inject anything into the code. It's not a framework. It's not like Angular or React. It does things on my machine, and once I'm done, it's normal JavaScript. The next thing was excellent editor support. I built Slack for all platforms, Windows, macOS, Linux, and our developers have strong opinions on which editor to use. Maybe some of you are the same way. Some of you want to use Vim. Some of you want to use Atom or Visual Studio Code. We needed something that was supported in all editors. And since we're already talking about support, we also use a lot of NPM modules. And we needed something that works well with NPM modules. TypeScript seems to be the thing that is most supported by other providers. It's very easy to find types for any kind of module. But even better is that TypeScript works very well with modules that don't have types. That's the crucial part. It doesn't require a lot of work for me to work with any module out there. If a module doesn't have types, that's fine. We can deal with it. So the last point is naturally that it has types, which might not mean much, which is why we're going to jump into an actual demo. So what I want to do is I want to show you a little bit about the beginnings of TypeScript, the first couple of minutes with TypeScript. So let's just go and do that. Just going to jump ahead here and do this. Okay. So what I have here is a little bit of JavaScript, right? This is some classic, very boring JavaScript. And if I'm the person who's now calling this code, I don't really know how this method works, right? There's nothing in my editor that tells me how this method works. Visual Studio Code is pretty clever. It sort of understands where the function comes from, but that's it. There's nothing here that keeps me from calling it like this. My editor is perfectly fine with that. And if I make this mistake, the next time I'm going to find it is on my customer's machine. There's nothing between me writing this now and my customer that is going to catch this error. I mean, maybe I have unit tests, and maybe they're going to find it. But realistically speaking, nothing is going to find this error, right? And when we start doing TypeScript, the first thing we can do that is very simple is that we just rename the file. So right now, this file is called demo.js. And I can just rename this file to demo.ts. And that's, in the beginning, all I had to do, right? And this was very important for Slack. We're currently moving the remaining JavaScript files over to TypeScript. And when I say remaining files, I'm talking about roughly 20,000 files. None of us can just stop and start porting the whole thing over. We have bugs to fix, features to write. The fact that I can change my file and use TypeScript without actually changing any code just yet is really, really big. It allows me to change a code base and sort of piece by piece, whenever I have time, improve my actual code. But the other thing we notice here, and this is quite nice, is that now that I'm here, TypeScript has immediately found its first little bug, right? I haven't changed any code, but immediately TypeScript is like, you can't do this. This is not allowed. Previously in JavaScript, there wasn't anything that found this error for me, but TypeScript, without me specifying anything, already realizes that up here I have an array, and because I have an array up there, it thinks down here, oh, you probably want an array, right? That's probably what you want. And that works out all right, and that's already pretty powerful. And at Slack, we had a bunch of those instances. We had a lot of occurrences of us just turning on TypeScript, and TypeScript immediately finding small bugs without us changing anything. Happened right away. And not because we're bad developers. I mean, we might be, but most likely it's because those bugs keep happening over time. If you have 50 promises that call each other, eventually you're going to find these little bugs. Now that TypeScript is helping me out here, we can actually specify a few things, right? So if I go down here, the other thing that I'm noticing is that if I want to work with result right here, and I just figure out what result is, this thing immediately knows what result actually is, because TypeScript is clever enough to infer what is going on. And by the way, this is not Visual Studio Code, this is TypeScript. You can get this auto-completion in every single editor that supports the language server. And this is not Visual Studio Code, it's TypeScript. And if I want to use any of these methods like shift, right? I can use shift, and TypeScript can help me out and figures out what is actually going on here and how the methods are being overloaded. So if I, for instance, go with result.fill right here, it knows the various overloads, it knows what I can put in. And if I want to, I can actually look at the type definition for that method. So I can go ahead and say, go to type definition, and it opens up this file, which tells me a little bit about the code that we're in. And one thing I want to point out here is that this is a type definition file, which is how TypeScript works. So in TypeScript, it has these definition files that explain how individual methods work, what the objects are, what the properties are. And this is the file for just the array, right? It's 500 lines. All of JavaScript, just for the DOM, is about 40,000 lines. And if you're a developer right now, you're supposed to know all of this. You're supposed to know this without any help. This is supposed to be in your brain, right? Whenever you call fill, you're supposed to know how to call it, what kind of parameters there are, what the return object is, whether or not it changes the prototype or not, whether or not it changes the input value. You're supposed to know all of this by heart. And just by renaming this file, I don't need to memorize any of this anymore. I can just forget about it, right? I don't actually know by heart how fill works, but that's fine because now my editor knows, right? And if I put something in here that doesn't make sense, then that's fine. If I put in this and then I give it a string, it will complain and say, hey, you can't put a string there. That doesn't work, right? So that's already a pretty big benefit. So now that we've done that, let's go a little bit down and actually figure some more things out. The other thing is that we can now actually go ahead and turn this into a real TypeScript project, right? So I'm going to close this, and I'm going to start setting up a TypeScript project, which I do with TSC, which is the TypeScript compiler. So if I run TSC init, I now get a tsconfig file. And this tsconfig file describes how TypeScript should compile my code. Right now it's very simple. The only thing that we have actually specified is that it wants to compile my TypeScript to ES5, which is a slightly older version of JavaScript. But that works out for me. So the next thing I can do is I can start the compiler so we can actually see what TypeScript is doing. So let's go ahead and do that. We've now started the compiler in watch mode, right? So what's happening is that TypeScript will compile my TypeScript file to JavaScript every single time I change my file. And let's actually look at these files side by side. So let's take this. There we go. And there's a few things here I want to point out. The first one is that the code on the right, this code, this JavaScript code, this is a really big deal for me. TypeScript didn't dramatically change my code. This is sort of the JavaScript I would have written if I didn't have TypeScript, right? There's a few changes here that if you look carefully, you will notice. So for instance, my arrow function was compiled down to a normal function because I specified ES5. But generally speaking, TypeScript leaves my code alone. And if you look at some other tools, some other compilers, I really appreciate how my code is not on just one line and a complete garbled mess. I can actually read this as a human being and understand what's going on. So now that we have the compiler running, we can actually start doing things and specify the actual types that we have. So the method is called sortPeople. So let's go ahead and actually define an interface. I'm going to put the microphone down for just a second. So I've now defined an interface, which you might be familiar with if you use Java or C# before. But I can now specify what my sortPeople method is actually supposed to do. So I can say what I want is I want input to be a person array. There we go. I'm going to say it's an array. There we go. So now that this happened, there's something I want to point out. Just with this definition, TypeScript can immediately figure out how my code works and can analyze how the code flows through the whole method. So there's a mistake here, which I would have not noticed before, but TypeScript noticed right away, right? Local compare does not exist on the type string because I forgot the E, right? So TypeScript has understood that because person has a property called name, and because name is a string, that my A right here is a person, and that name is a string, and that therefore this is a mistake. And this is a mistake that could happen to me really easily. This is a mistake people make all the time, right? This is something I would have straight up committed to production. I would have run on slack.com, would have never found it. A unit test may have caught it if I had written a smart one, but localization unit tests are very rare. Most people do not write them, I'm afraid. So this is a classic thing that only TypeScript has ever actually solved for me. So I can just go ahead and say, all right, quick fix, please actually fix this for me. I didn't even have to tell TypeScript what the right thing is. TypeScript was, all right, this is what you actually want, right? And if we save this file, one thing I want to point out, so this file is now saved. This file on the right has not changed. The types are only on my machine. Nothing has changed in the JavaScript. The types simply get removed. The only thing that changed is that my local compare is now spelled correctly. But there's nothing here that I'm shipping to the customer. There's not a performance impact. All of this just runs on my machine. And some of you might want the compiler to help out a little, right? Maybe you want to do a little bit more. So TypeScript right now is really unobtrusive, but we can sort of define how exactly we want things to work. So if I go into my tsconfig here, we can change some things, right? We can say, okay, ES5 is fine, but I actually want ES6. So if we change that, I save, we now immediately get this little arrow function right here, right? But it goes a little bit beyond that, and I think I want to show you what I mean by that. A typical example is that TypeScript will support the latest and greatest in JavaScript and will handle using that on an older machine on something like Internet Explorer 11. So right now, person is an interface, but what if person was a class, JavaScript class? So I'm going to go ahead and write this class real quick and turn that into an actual person class. All right, so now I created a class, right? And if I save this, my file now actually gets a class. And this is a JavaScript class, right? This is ES6. But if I go back to my tsconfig and change it back to ES5, again, TypeScript, give it a second. Come on, you can do this. The crux of live demos. There we go. Okay. Now we have it convinced. So again, what I want to point out is that this is roughly the JavaScript I would have written if I had just written JavaScript for ES5. There's not 10,000 lines of boilerplate code here, right? This is not anything that goes beyond the immediate thing that I needed. There's no additional 5 megabytes of framework that make this class work. It's just a function class, the same way we would have done it in the past. And it's even nice enough to put this in here so that someone else reading the code will understand what is going on by default. So that's pretty much the whole demo. And the point of this demonstration, excuse me, let's just start this again. So yeah, the point of this whole demonstration was to show you that TypeScript can be really lightweight, right? So that's the biggest strength that I see, because if you have a large code base and you can't afford to port the whole thing over, this lightweight start is really, really powerful. You can just turn on the compiler. You don't have to worry about anything else. And it's great for code bases that you simply cannot afford to port over in one go. So let's summarize what that actually means for Slack. So at Slack, we started by just turning on the compiler. That's all we did. The first start was to just turn on the compiler. And we just thought, OK, so this is going to run every single time we save code. That's fine, I guess. There's really no harm it can do. Doesn't change what is running on the customer's machine, so how bad can it be, right? It's like prettier or linter. And as I already said, right away, TypeScript found about 30 different bugs. All kinds of bugs that you only make when you pass an object through 50 different promises, and some of that code might be native, so you can't really see where it's coming from. It might be coming from C++. So even before we wrote a single line of TypeScript was immensely powerful. It immediately fixed errors that were actually on customer machines. So we just did that, just turning on the compiler. And then our initial plan was to sort of keep working on actual bugs and features and have this TypeScript thing on the side. And we wanted to slowly port individual files over. We were sort of thinking that we would use TypeScript only on new files. So at Slack, we have a lot of iterative development. We keep working on features over and over again. And it really takes us a little bit of time before we like what we have written. So more often than not, we will write some code, immediately throw it away, and write it in new. And we were thinking that with this method of only doing new files, TypeScript would slowly take over, right? Over time, we thought eventually everything will be TypeScript by the time we have touched all the files. But what happened right away was within a week, working with JavaScript felt a little dirty, a little messy. And the thing that I think I underestimated and my team underestimated is the power of autocomplete, the power of your editor knowing what you should do. If any of you have worked with Visual Studio or Eclipse, you might go, well, duh, autocomplete isn't that new. C# developers and Java developers had it for years now. But it is really, really powerful to know what your code is expecting. And the example I give is that I recently started working with Koa, which is sort of like Request. It's a web framework. And Koa is entirely written in TypeScript, and while I was building my new app, I didn't have to read the documentation a single time, right? Not once. So this thing that people do where they very frequently go to lodash.com and read the documentation to see how methods work, I didn't have to read the documentation once, because even though I didn't know how methods actually work, TypeScript did, and that was good enough. TypeScript was the only one who really needed to know how this damn thing works, and I could figure it out from there. And what that means is, for the Slack app, as soon as we started working with a single JavaScript file, you had the strong incentive to just turn it into TypeScript, right? You very quickly just like, ugh, this is kind of gross. Let's just quickly turn this file into TypeScript, and then I can move on with my life. And that was really powerful. That changed quite a bit for our users. And if you don't use any of the advanced features, you can very quickly port files over, right? Sort of like what we did just here with sort people. You just rename the file, add the 2 or 3 types, and move on before you go and do anything fancy. And that's really helpful. And the best thing that happened was the notion of committing with confidence. So in the past, whenever I committed code to production, the only thing that ensured that I didn't commit any mistakes were my coworkers. And if any of you use Slack, I'm still, to this day, my biggest fear is that you cannot use Slack is because my team made a mistake. And TypeScript really helps, right? It might still be bad code, but fundamentally speaking, we know that it's structurally sound. We know that it's code that works. We know it's code that does not completely blow up. And that brings me to my first downside. The first thing that we found was kind of difficult. Many of us use linters, right? ESLint, for instance. And in the TypeScript world, ESLint has recently introduced support for TypeScript, but the major tool is TSLint. And TSLint is great, but it's not nearly as good as ESLint. So if you and your team come up with any kind of stupid rule that you want to enforce, if you want to say every single JavaScript variable now has to start with an emoji, ESLint will do that for you. It will give you a rule and we'll be like, yes, from now on, if the variable doesn't start with an emoji, I will throw an error. TSLint doesn't do that. TSLint is a little bit more rigid, so we at Slack had to let go of some rules. But as I said, ESLint has very recently started to announce support for TypeScript. It's not quite there yet. So long story short, if you have a strong linting community right now, moving to TypeScript will be a little difficult. And maybe the biggest downside is that TypeScript can look really, really scary. So my team at Slack is filled with native developers. We write a lot of C++. We all have a background in C# or Java. But when you hire for JavaScript positions today and you hire web developers, you often need to work with people who have never seen a typed language. They have never seen Java. They never had to write C#. They never had to write C++. And for them, TypeScript, especially the advanced usage, can be a little confusing. Words like interfaces, generic types, union types, that stuff can be a little scary. So every single time you start working on Slack, I basically need to teach you a little bit about native development before you can get started. And I have an example. This is what I find to be the most scary line of TypeScript in Slack. This is production code. And if you have never worked with a typed language, it might actually take you a minute to figure out what is on this slide, right? Maybe it even takes you 5 minutes. If you read this right now and you have no idea what's going on, that's fine. You don't have to. You're a web developer. But that's a tax we sort of pay, right? Every single time we start onboarding someone at Slack, there's this onboarding tax that I pay of teaching the person the difference between JavaScript and TypeScript. And it's more than nothing. And eventually you will start writing pretty advanced typing code, right? But that being said, I really very strongly believe that all of that is worth it. Slack's application is certainly better. We started porting over just the Slack desktop application, but we're now starting to port every single line of JavaScript at Slack over to TypeScript, which is a project that has just begun. And even if this code is a little dangerous and a little scary to you, it's certainly something that I can heavily recommend. I'm now a big fan of TypeScript, despite the fact that this is very complicated and very scary, right? It's worth it. So, in summary, please use TypeScript. It's good, especially if you have a lot of code. If you have any questions, we have a lot of time for questions right now. I love to answer them. But also, very importantly, I brought a bunch of Slack stickers. If any of you want any, please come and find me because I have a lot of them. You can also find me on Twitter if you have any questions. And I'm happy to help you out with TypeScript. And so is the whole TypeScript community, which is filled with a bunch of really nice people who helped Slack a lot when we got started. When we got started at Slack, the TypeScript team invited us to Seattle, and we had a little chat about all the things that we didn't like. And they fixed them. They're really nice people. So that being said, thank you very much for the invitation, and thank you for your time.